Hello and welcome to GER Hub Mathematics and Statistics Lessons. Thank you very much for subscribing to our channel so far. Thank you for all your subscriptions. We are very grateful. Please like our video, share our video, watch our video, and most importantly, please keep telling people about our channel and what we stand to offer them. Please subscribe to the channel if you haven't, and keep telling people to subscribe to the channel because our contents are for them. Thank you very much. Thank you very much. And thank you very much. Now let us begin. So we will start with this problem that says change each of the following index forms into their logarithmic forms. I'm going to show you two ways to go about doing that. So now take note, 2 raised to the power 6 is 64, means that the logarithm of 64 in base 2 is equal to 6. That is one way to go about changing a number in exponential form or index form to the corresponding logarithmic form. All you have to do is to apply the definition of logarithm. So one way to go about putting this number in its logarithmic form is to use the definition of logarithm, that the logarithm of a number in a given base is that number to which the base must be raised to get the number. So if I want the logarithm of 64 if I have 2 raised to the power 6 equals 64, it is only because the logarithm of 64 in base 2 is 6. Okay, now if you don't want to go that way, then another way would be to take the logarithm of both sides. So if you take the logarithm of 2 raised to the power 6, if you take the logarithm of 2 raised to the power 6, it will mean taking the logarithm of 64. Now that can only be done in base 2. So if you take the logarithm of 2 raised to the power 6 in base 2 and you take the logarithm of 64 in base 2, you end up having 6 log 2 equals log 64 base 2. Now this would imply what? It means what we have just done here is to apply the law of logarithm. This law of logarithm that says the log of a raised to the power m in a base n is the same as m times the log of a in that base n. So that's the law we applied here. We are going to apply another law over here, and that law is the law that says log of a in base a, the log of a number to that same number as its base, is 1. So that would mean log 2 is 1. So that would be 6 times 1, giving us log 64 to base 2. And what is log 64 to base 2? It is now 6 times 1, which is 6. So whichever way you do the problem or you get the problem solved, boils down to the same thing. Now, two ways to go about interpreting this is to use the definition of logarithm or to just take the log of both sides. So when you take the log of both sides, it will put that number in index form in its corresponding logarithmic form. So let us apply that now to problem 1b, where we have 6 raised to the power 3 equals 216. If you understand the definition of logarithm, it simply means if 6 raised to the power 3 equals 216, it is only because the logarithm of 216 in this base 6 is equal to 3. So you see how simple it is. 6 raised to the power 3 is equal to 216 only because the logarithm of 216 in base 6 is equal to 3. So that is one way to convert a number in exponential form or index form to its corresponding logarithmic form. If you don't want to go that way, then take the logarithm of both sides. So I'm going to take the logarithm of 6 raised to the power 3 in base 6, and I'm going to take 216, the log of 216 in base 6. Now when you do, it will give you 3 log 6 to base 6, still because of this law. And that gives us log 216 to base 6. Now again, because of this law over here, log a is equal to 1. The log of anything to that same thing as the base gives you 1. So that will be 3 times 1 equals log 216 to base 6. And log 216 to base 3 times 1 is 3. And that gives you log 216 to base 6 equals 3, which can be written as log 216 to base 6 is equal to 3. So that is a way, those are two ways of converting that number in index form to its corresponding logarithmic form. Now let's go to C. For C, we have 0.01 all squared is equal to 0.0001. Now, what am I going to do? I'm going to, I could write this to start with as 1 over 100, okay, because it moves 1, 2 times the point, and that will be squared. This will give me, on the other hand, it will give me 1, 2, 3, 4, 10 raised to power 4, or 10,000 to start with, okay. Now, this will give us 1 over 10 raised to power 2, and this will give us 1 over 10,000. Okay, now if you do this, this will give you 10 raised to power minus 2 equals 10 raised to power 4, 10 raised to power minus 4. Okay, now this is, on this hand, 1 over 10 raised to power 2 all squared. Take note, and this will be 10 raised to power minus 2 all squared. Now, one way, if you look at it clearly, you end up going in rings, in circles. So what we have to do to this problem is to start with taking the logarithm of both sides. That is, take the logarithm of both sides. That will give you 0.01. But I would love us to go by way of definition. Now, 0.01 all raised to power 2 is equal to 0.0001 means that the logarithm of 0.0001 in base 0.01 is equal to 2. So if 0.01 all raised to power 2 is equal to 0.0001, it means that the logarithm of 0.00001 in base 0.01 is 2. Now, let's see if that is true. So that is just one way of doing it. I just wanted us to start that way. Now, if you don't want to go that way, then you can go the other way around. So let's simplify this to start with. Let's simplify this. If you do this by the definition, you end up seeing that this will give you 1 over 100 as the base, and this will give you 1 over 10,000 as the number whose logarithm we want in that base, 1 over 100, and that will give us 2. Now, if you move ahead, you end up having this. You end up having the problem reducing to this. That is, you end up having log 10 raised to power minus 2 equals 1 over 10 raised to power 4. Okay, now that will be equal to 2. I'm looking for an alternative way of writing this. So this will be 10 raised to power minus 2 equals 10 raised to power minus, okay, log 10 raised to power minus 4 in the base 10 raised to power minus 2 equals 2. Now, if you apply the laws of logarithm, this will give you minus 4 log 10 raised to power minus 2 and 10 equals 2. And if you further apply that, just to verify, you end up having minus 4 times 1 over minus 2 log 10 equals 2. Now, why am I doing this? I just want to show you that this expression is correct in the logarithmic form. This is the logarithmic form that they want, and this is just a check to show you that it is correct. Okay, so minus 2 cancels minus 2 to give you plus 2, okay, and plus 2 log 10 is what you have. Clearly, log 2 plus 10 is equal to 2, because this is 2 times 1, log 10 is 1, and that gives you 2. So it is actually correct. Now, that being said, let us go to problem number 2. In problem number 2 of this, we have change each of the following index forms into their logarithmic forms. Again, we are to change each of these index forms into their logarithmic forms. And I'm going to start with A, 2A. In 2A, you have 3 raised to power 5 equals 243. So, 243 is 81 times 3, which is 3 times 3 times 3 times 3. And that will mean 3 raised to power 4. Okay, or 3 raised to power 5 rather. So what I want you to do here is to go by the definition. The question is, why is 3 raised to power 5 equals to 243? 3 raised to power 5 is equal to 243 only because by the definition, the logarithm of 243 in base 3 would give you 5. So 5 is the logarithm of 243 in base 3 only because 3 raised to power 5 will give us 243. Now, if you don't want to go by the way of definition, then go by the way of taking the logarithm of 243 in base 3 and the logarithm of 3 raised to the power 5 in base 3. That will give you log 243 in base 3 equals 5 log 3 to base 3. And log 3 to base 3 is 1, so that gives us 5 times 1 equals log 243 to base 3, and that will be log 243 to base 3 equals 5. So this is another way of putting that number, this expression, in its logarithmic form. Now let's go to B. For 2b, we have 25 raised to the power half equals 5. Again, why is 25 raised to the power half equal to 5? It is only because the logarithm of 5 in base 25 is equal to half. So why is that so? 25 half is the only number to which you would raise 25 to get 5. So that is true. Now if you don't want to go that way, by the definition, like I said earlier on, all you have to do is to take 25 raised to the power half, take it in base, take both sides in base 25, and that will give us logarithm to base 25 of 5. Now if you take both sides, this will give you half log 25 25, and this will give you log 5 to base 25. Now log 5 to base 25 clearly is equal to half times 1. Why? Log 25 to base 25 is 1. Log of anything to that thing is 1. So that gives us log 5 to base 25 equals half times 1, which is half. And this becomes the logarithmic form of this expression. Okay? So there are two ways basically I have been using so far. Either you go by means of the definition, by the way of the definition of logarithm, that the logarithm of a number in a given base is the number to which the base must be raised to give the number whose logarithm we want. So if the logarithm you want is the logarithm of 5 in base 25, then the only number to which 25 must be raised, which is half, is this, in this case, becomes the logarithm. Now let's go to C. Now for problem 2C, you have 3 raised to the power minus 3 equals 1 over 27. We are asked to put this expression in its logarithmic form. Again, we can go by the way of definition. By the way of definition, 3 raised to the power minus 3 is equal to 1 over 27, only because 1 over 27, the logarithm of 1 over 27 in base 3 equals minus 3. And that means, by definition, the logarithm of 1 over 27 in base 3 is that number to which you would raise 3 to give 1 over 27. And the only number to which you would raise 3 to give 1 over 27 is minus 3. So, if you don't want to go by that means of converting this index form to logarithmic form, again, I'll tell you, like I started in this video, there are two ways to go about doing it. Either you go by way of definition or by way of taking the logarithm of both sides. So one way to put this number in its logarithmic form is to go by means of definition. And by definition, the logarithm of a number, say 1 over 27, is the in a given base 3, is that number minus 3 to which 3, the base, will be raised to get 1 over 27. And that makes the logarithmic form. Now, if you don't want to go that way, let us go by taking the log to base 3 of both sides. So I'm going to take the log to base 3 of 3 raised to the power minus 3 and the log to base 3 of 1 over 27. That will end up giving us minus 3 log 3 to base 3 equals log to base 3 of 1 over 27. And clearly you will end up seeing that this is minus 3 times 1. Again, by that law, log of anything to that same thing is 1. And this will be equal to 1 over 27, log of 1 over 27 to base 3. So that will end up giving us log to base 3 of 1 over 27 equals minus 3. And we end up having the same result as above. Now the last problem in this video and in problem 2 requires that we do this. It requires that for D, we put this number 4 raised to the power minus 4 equals 1 over 256 in logarithmic form. So again, ask yourself the question by means of definition, why is 1 over 256, why is the logarithm of 1 over 256 in base 4 equal to minus 4? So the only reason why 4 raised to the power minus 4 is equal to 1 over 256 is simply because the logarithm of 1 over 256 in base 4 is equal to minus 4, and that puts this exponential form in its corresponding logarithmic form. If you don't want to put it that way, then you can go by means of taking the logarithm to base 4 of both sides. If you take the logarithm to base 4 of both sides, this will be the logarithm to base 4 of 256, and that will end up giving us minus 4 on the left hand side times log 4 to base 4 equals log 1 over 256 to base 4. Okay, now when you do that, you end up having minus 4 times 1, because log 4 to base 4 is 1, and that will give you log to base 4 of 1 over 256, and that becomes log to base 4 of 1 over 256 is equal to minus 4, and that solves that problem. So thank you very much for watching this short video on solving problems on indices part 2, the solver series on indices part 2. Do like our video, share our video, watch our video, and most importantly, if you love this channel and you love our content, please subscribe to our channel. Keep subscribing to our channel. Tell a friend, tell a brother, tell a sister, tell a family member, or anyone around you who needs our mathematics and statistics content, as well as our research content. Tell someone about GER Hub to subscribe to our channel. Thank you very much. Thank you very much. And thank you very much.